we will be talking about KMJ 2022 and 2023 questions. Okay, so let's look at the first question. Okay, so here is a diagram showing the relative abundance and then the mass for chlorine. So for chlorine, we have two isotopes. One is isotope chlorine 35 and chlorine 37. And the relative abundance for chlorine 35 is 3, chlorine 37 is 1. Okay, so first we have to write the isotopic notation for all the isotopes of chlorine. So it is based on these two. So we have two chlorine isotopes. One is 35, one is 37, and their proton number are the same, 17. But for writing the isotopic notation for chlorine or for any atom, we have to write using this. Okay, so let's say an atom is called A, and then it's here B, here C. So B is actually the nucleon number, which is proton plus neutron, and then for C is proton number. Okay, so here it is proton number, so here is the two nucleon number, or the mass also we called. Okay, so next we have the relative atomic mass of chlorine. We have to calculate it. So as we know that we have to first find the average atomic mass, but finding the average atomic mass, we have to apply this formula, KMPK, the short form KMPK, and then K is actually the relative abundance. Okay, and me is actually the mass. Okay, so here 3 times 35, and then 1 times 37 over 3 plus 1. This one is 3 plus 1, but not 100%, because not every case will be 100%. We have to base on the question, and for this question we can see at here relative abundance we have 3 and 1 only, not like 91% plus 0.8, not like this 91%, 8.3, 1.7, oh sorry, 0.7, not like this. Okay, so for this case it's 3 plus 1 only. Okay, so after that we find the answer, 35.5 AMU. Okay, please note that we have to use this unit A.MW, which is atomic mass unit. Okay, so next we have to convert it into relative atomic mass. So we can just simply divide it by 1/12 times 12 AMU, which is 1/12 times carbon 12. It is used as the unit to find the relative atomic mass. Okay, so after that we divide, and then we find 35.5. It is without unit. Please be noted that. And then let's see the second question, B1. A cyclic alkane has a molecular weight of 128 gram per mole. It consists of 7.58 mole C and 6.29 mole H. Determines empirical and molecular formula. So this alkane is basically, it got C component and got H components only. So but we don't know actually how we have to write, whether it's 1, 2, 1, 2 or 3, 1, 2 or 3, we don't know. So we have to find the empirical. After that, we find the molecular formula. Okay, so first, we have given the molecular weight 1 to 8, and then it has given the mole for each atom, C and H. C is 7.85, H is 6.29. But we have to find the simplest mole ratio in order for us to write the empirical formula. So I divide 6.29. We have to divide the smallest mole, which is this one, 6.29, so equals to 1.25. And for H, 6.29 divided by itself, 6.29 equals to 1. But haven't finished. We cannot take 1.25 to become the answer, to become the simplest mole ratio. We have to make it into whole number. Whole number means 1, 2, 3, 4, blah blah blah. And then here we have 1.25, right? So we can make it into whole number but times 4, and then we get 5, and then here times 4 equals to 4. So after that, we just find the empirical formula, which is C5, C5 and H4. Here got C5, right? And here got H4. So C5, H4. And then after that, by using the empirical formula, we can find the molecular formula. Okay, so C5H4 N, we don't actually, N is what? Equals to 1 to 8. So we find N by substituting the average mass for the C and H, which is 12 and 1. 12 times 5 plus 1 times 4, and equals to 1 to 8. And N, to find N, we need to divide by these things. So become 1 to 8 divided by 64, and N equals to 2. But haven't done yet. We have to substitute back into this thing. So molecular formula equals to this one. So we have find N, right? N is equals to 2. Then we times inside. Then we find the final answer. Molecular formula C10H8. Okay, so for the next question, B2. Second question, hydrogen peroxide H2O2 is a powerful oxidizing agent used in concentrated solution, in rocket fuels, and in dilute solution as hair bleach. An aqueous solution of H2O2 is 30% by mass. Density 1.11 gram per ml. Calculate its molality. Okay, so we have to know that first. What is molality? Molality is actually the number of mole of what? Of solid. Divide by what? Divide by mass of solid. So basically, we have to find these two items in order for us to sub inside the formula. Okay, so we first find the mass of solid. From the given data, it shows that the aqueous solution of H2O2 is 30% by mass. So H2O2 is actually equals to 30%. So from here, we can know that here is 30%, right? So to find the mass, we can just assume it to become 100 gram, and then we can find the aqueous solution of H2O2 is actually equals to 30 gram. Okay, so here we assume the mass of we assume mass of aqueous solution of H2O2 is 100 gram. Okay, so here is 30 gram. 30 gram is for H2O2. Okay, so here this is H2O2. This is solute actually. This is not a solution. So 30% right over 100 gram. So it means like a solution, aqueous solution. So here it is aqueous H2O2. But aqueous H2O2 is actually divided into H2O2, which is a solute, and then the solvent H2O as always. Okay, so we have to find the H2O, right? The solvent, the mass of solvent. So we have to first find mass of solute first, since we have already have the information 30%. This is solute, so we just use this formula to find the mass of H2O2. We have assumed mass of aqueous solution of H2O2 is 100 gram, so we just put inside, so we just can find the mass of H2O2, which is equals to 30 gram. Then after that, we can find the mass of solvent first if we want. So mass of solute plus mass of solvent equals to mass of solution. So mass of H2O2 plus mass of H2 equals to mass of H2O2 solution. So 30 gram plus mass of H2, which is the unknown. The thing that we need to find is equals to 100 gram. Then mass of H2O is equals to 70 gram, which is the solvent, mass of solvent. After that, here we have to find the number of mole of solute. So we need to find the mole of solute H2O2. Okay, so here, right? So we have know the gram already, so we just divide by the relative atomic mass. Then we can find the answer 0.8824 mole. We need to put in 4 decimal places before it is the final answer. Okay, so lastly, we can just simply find the molality, which is number of solute, which is the H2O2, right? And then mass of solvent, which is the H2O. Okay, so 0.8824 mole divided by 70 divided by 1000 kg. We have to put in kg, but not gram. Okay, please note that. So the final answer, we will find 12.61 mole kg negative 1 or m, not small m. Okay, so this one also need to be in 2 decimal place. As always, for the final answer must be 2 decimal place. Okay, so lastly, we have this question. The following reaction takes place in an acidic condition. Acidic condition means that we have H+. Please note that. Okay, so this is the thing, and then we need to balance it. Write a balance equation for the above reaction. So we have to always be reminded that we have to separate into 2 parts. What is oxidation? What is reduction? So which is oxidation? So the oxidation is the part that receives oxygen. Okay. Reduction means that the part that reduces oxygen. That's simple, right? Just remember that. Okay, so Br2 equals to BrO3 minus. Initially it's like this. So we first balance Br first, which is aside the atom O or H, and then after that we have 6O, right? So here we need to plus 6H2O. After that, here got 12H2, right? 12H, right? So we need to add 12H plus. And at last, we have to balance the oxidation number. Here we have 0, but here we have plus 12 minus 2, so it's plus 10. So we have to plus 10E, just like this. And then for reduction, we have H2O2 become H2O. H2O2 become H2O. So initially it is like this. Okay, so H2 is balanced, right? But O haven't. So we need to add 2 here in order to balance. But here, now, has increased from 2 to 4. So here need to add 2H plus to balance the H and O. Okay, so lastly, we have to balance the oxidation number. So here is 0, right? So here is plus 2 already, so we need to add 2E minus. Okay, so it becomes like this lah. Okay, so finally we have to write a balanced equation for the above reaction. So we can simply combine the oxidation and the reduction together. Okay, but before that, we have to make sure the electron number are the same. So we times the reduction equation with 5 in order to become 10E minus, and then we deduct. Okay, after we deduct, just put here down Br2 plus 6H2O plus 10H plus 5H2O2, arrowhead 2Br03 minus plus 12H plus 10H2O. But haven't done yet, we have to make sure the equation is the simplified form, because here got 6H2O, here got 10H2O, here got 12H plus, here got 10H plus. We have to make sure that only either one side, either here or here got H plus, here or here got H2O, either one side only. We cannot have both sides. So we just put here to here. After we put here, we will divide by 4. We will subtract by 6. So 10H2O minus 6H2O becomes 4H2O. And then 12H plus minus 10H plus equals to 2H plus. So finally, this one will become disappear, and this one become 2H plus, this one 4H2O. So this will be the final equation. Okay, so for the last question, D, sodium nitrate can be formed by heating the sodium metal under nitrogen gas. Okay, this is the equation. So it states that here 38.0 gram of sodium with an excess of 0.3 mole nitrogen gas. The percentage yield of Na3N produces 75.1%. Okay, so first Roman, what is the actual amount of Na3N produced in gram? Okay, to find this, we have to know that percentage yield is actually equals to actual yield divided by theoretical yield times 100. So we have the percentage yield 75.1. We have to find the actual yield. So we have to first find theoretical yield first. Okay, so how to find the theoretical yield? So it's like this. Okay, so we have to first find the mole of Na, and then we times by the molar mass. Okay, we have to first find the mole of Na. So it's like this, 38.0 gram divided by molar mass 23, and then we find the mole 1.6522. For decimal place, please remember that. And then from the equation, we know that 6 mole of Na is equivalent to 2 mole of Na3N. So 1.6522 mole of Na is equivalent to 0.5507 mole of Na3N. So here is gotten from 1.6522 divided by 6 times 2, and you will get this one. And then after that, we find the theoretical yield of Na3N by multiplying with the molar mass of it. Okay, so 0.5507 mole times 23 times 3 plus 14 G mole negative 1. So we get the answer for this 5.71 gram. So since we already have the theoretical yield, the theoretical U of NH3N, we just substitute inside. Okay, and then we find the actual U of NH3N, 34.33 gram, 2 decimal place. Okay, so lastly, we have to determine the mole of nitrogen gas remain after the reaction completed. So here, nitrogen gas. Okay, so from the equation here, we know that 6 mole of Na is equivalent to 1 mole of N2. So it's like this lah. So 1.6522 mole of Na is equivalent to this one, and this one is get from 1.6522 divided by 6 times 1. Okay, so this one is the we used. So to find the mole of nitrogen gas remain after the reaction completed is equals to 0.30 mole minus 0.2754 mole, and we get the final answer 0.0246 mole.